All right, so welcome everybody. I'm going to post a video here. This is my second attempt at this video as well. I don't know why I did the same thing to GAC2 today, but let's take a look. So, linear functions, exponential functions. So far, the last couple days, we've talked about arithmetic and geometric sequences, right? Well, these sequences are actually specific type of functions. So an arithmetic is obviously adding or subtracting like we talked about before. Well, it's a type of linear function. So they actually increase with a common difference, which we talked about yesterday, making their graphs straight lines. All right, so linear functions can be represented as f of x equals mx plus b, which you probably know it as y equals mx plus b, but it's the same thing, only in function notation. Okay, same thing with exponential. You may have seen this before, but it's y equals a times b to the power of x. All right, that's an exponential equation. So arithmetic functions look like this, or linear functions, or straight lines. Exponential functions look like this, or like this, right? Okay. So we're going to use Desmos here. We're going to compare a couple things. So we have two functions listed in number one. We have this linear function, which is 2 times x, and we have this exponential function, which is 2 to the x. Okay. All right. So let's just take a look first. I'm going to pull up Desmos here. Let's see what they look like. Let's see again. 2x and 2 to the x. So 2x and 2 to the x, raise it to the exponent. All right, so if we take a look, I actually need to erase this. I'm going to flip them around here. So this red is 2x, and blue is 2 to the x. All right, so as you can see, the blue line, which is the exponential, looks like it gets way bigger as you continue right, but then as you go left, it kind of flattens out, whereas the red line is pretty constant the whole way. So the question asks, let's compare. Is the red graph, so the linear graph, bigger than g of x, or the blue graph, for all x values? So what does that mean? What it means is I go along the x-axis, are the red y values going to be bigger at all times? Well, if I'm looking to me, off to the right there, if you see where 10 is, on the x-axis, the red, right here, the red's lower than the blue, right? So that immediately is going to be false. We know that to be false. Okay, so what about the other way? So is the blue bigger than the red at all times? Well, let's look. Kind of looks like that. Let's zoom in and make sure. And you can kind of see as I get closer and closer here. There is a component where the red is taller than the blue right here, right? The blue's on the bottom, so that would also be false. Okay, how about the red bigger than blue? So the linear function bigger than the exponential function when x is bigger than 2. So if I go to where 2 is, okay, that's right here. So is red bigger than blue there? Well, no, actually it's the opposite, right? So that makes this one false. And then this is the opposite of that, where it says blue is bigger than red at past 2. That's true. Okay, because red is taller. Blue is taller, I'm sorry. Okay, so let's look at a couple other ones here. All right, it says, for what domain would the following be true? So now they're changing on us here a little bit. So f of x is x squared, and g of x is 2x. All right, so it wants to know, okay, where would this be true? So where is the red graph less than the blue graph? Well, if I'm looking at this, the red graph is on the bottom between the x values of 0 and 2. At 0 and 2, though, it's not included because they're the exact same there. The red and blue graphs are the exact same. All right, how about the opposite? When is the red graph bigger than the blue? Well, pretty much anywhere along this right side after, what is that, 2, and on the left side it gets bigger as well, anywhere after 0. So we would say from 0 So 0 to x, and x to past 2. 0 is less than x. No, I'm sorry, I wrote that the wrong way. Okay. So there you go. It'd basically be from like negative infinity to 0, and then also, and that's a union from 2 to infinity. Okay, those spots. All right, so let's take a look at these other examples here and just kind of continue to compare functions. These are tables, and they want us to tell whether they are linear or exponential. All right, so remember that first we need to check the x values, make sure they go up by 1, which these ones all do. And then we're going to check the y values and see how they go up. Do they multiply? Do they add? Do they subtract? Like, what are they doing? Well, in this case, they're adding 2. So this would be linear, because linear in arithmetic graphs add and subtract. Okay, this one goes up by 1, but then this one goes up by 2, so it can't be adding. Okay, so if I times 2, that gets me it. So this would be exponential, because it's multiplying by a common ratio. Same with the graphs. This one's a straight line, so it's linear. This one is this like curved graph. Looks like this or this, so that would be exponential. Okay. Could be neither if it went like this, or like this, or like this, right? Exponential graphs only look like this, where they start out really slow and then take off really high, or they start off really high and then slow down almost to a stop, right? Those are exponential graphs. All right, so looking at these examples, determine whether each of the following is best represented by a linear or exponential function. So what we're talking about is, how does it change? What's the rate of change? Is it adding or is it multiplying? Gideon saves $5 every week. Okay, so first week he's got 5, second week he's got 10, third week he's got 15. This is adding, so this is linear. Mr. Miller uses a herbicide to kill the weeds in his yard. Each month, there are half as many weeds as there were the previous month. Okay, so let's just go with an example. 20 weeds, 10 weeds is half, 5 is half of that. Well, that's dividing by 2, right? Or multiplying by 1/2, so this is exponential. A population of mosquitoes triples every week. Okay, if I start with 2 mosquitoes, tripling would go to 6, tripling that would go to 18. This is also exponential. It's multiplying. Every month, 20 new people move into Hilliard. So 20 the first month, 20 more the second month, 20 more the third month. Okay, so this would be linear. Okay, let's look at a couple examples here. Chase has $100 in his bank account. He saves $20 per week. Fill out the table below and graph. All right, so after week 0, he's got $100 in his account. He saves $20 more per week, so we're adding 20 every time. Okay, let's put that on the graph. Let's go with the 100. Okay, this just means like a broken graph kind of deal. It's not broken, it's just saying like all the numbers leading up to 100 are below that. 40, 160, 180, 200, 220, etc. So week 0, you had 0, 100, 1 and 120, 2 and 140, and so on. Okay, so what is the domain for this function? All right, so let's think about this. Chase has $100. Well, can he have a negative number of weeks? Probably not, right? Not unless somebody created a time machine. So instead, we would say the domain for this function is from 0 to 4, or specifically, it doesn't really say he ever stops saving money, right? So I would even argue this is probably x is bigger than or equal to 0, right? Or from 0 to infinity. Does this represent a linear function, exponential function, or what? Well, as you look, it kind of looks like a straight line. It's adding every single time, so this would be linear, which would make it arithmetic. Okay, next example says the first year Josh had 20 fish in his pond. So after, or when he first starts, he puts 20 fish in the pond. And then the fish double in population every year. So after 1 year, he now has 40. After 2 years, 40 doubles to 80. 3 years doubles to 160. 4 years doubles to 320. Okay, let's go ahead and mark these ones. So 20, 40, 60, 80, 100, 120, 140, 160, okay, etc. So let's go ahead and graph this one. This one starts at 0, 20, then 140, then 280, then 3, 160, and you can see this is getting very big very quickly, right? So as he goes up, okay, you're going to be kind of like that. All right, so what is the domain for this function? Again, starts at 0, continues up. So x is greater than 0 or 0 to infinity. Does this represent a linear function or exponential? So linear would be adding, this is multiplying, this is exponential, and geometric. Okay. All right, last one here. Antonio and Juan are a 4-mile bike race. The graph below shows the distance of each racer as a function of time. What is the domain of Juan's function? So Juan's function is this one. And remember that domain are your x values. So domain starts at 0 and goes until 13. So there you go. Domain 0 to 13. Or you could do it this way, 0 to 13. Okay. Are these linear or nonlinear functions? So the question is not linear or exponential, but linear or nonlinear. So are they straight lines? Nah, they all have some type of curve to them, so these would be nonlinear. Next question says, who wins the race? So remember, the point of winning a race is getting to a point first, right? So it looks like Antonio kind of starts with the lead here, but then kind of slacks off, and then Juan overtakes the lead, and he gets to 4 first. So this would be Juan. For what domain is Antonio beating Juan? So when is green above that? Well, it doesn't include 0 because they start at the same point, but it does go up to 7, and then they tie it again. So this is between 0 and 7, but notice I'm not using the line underneath because he's not beating him at 0 and he's not beating him at 7. They're tied again. It could also look like this, 0, 7, and now we're using parentheses because 0 and 7 are not included. For what domain did Antonio not ride his bike? Okay, so that would mean, like, if he's riding a bike, he's going to be moving forward, right? So when does he stop? Oh, looks like right there, from time marker 5 to 7. So 5, and he stopped at 5, so we're using the equal sign. And he started back up again after 7. So 5 to 7. What domain is Antonio's graph? Constant. Okay, remember constant means it's the same pace. Okay, well, we could say here. We could also say right here, it looks like it's a pretty straight line. So we would say from 3 to 5 and from 5 to 7. So from 3 to 5 and 5 to 7. Okay. All right, that's it for today. Go ahead and fill out the exit ticket. Make sure to ask questions for these ones. Definitely put this in Desmos, okay? Number 3, put it in Desmos. Take a look at these 2 equations. All right, see which one's which. And same thing here for number 4. So f of x is bigger than g of x, and f of x is less than g of x. Kind of just like we did in the notes. All right, let me know if you have questions.